Pythagorean theorem tells us that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And this is what is used to derive the distance formula, because if we take any 2 points in space, and I want to find out this length right here, I can actually create a right triangle, and these are horizontal and vertical, so I can find this number easily, and I can find this number easily, and then I can use the Pythagorean theorem, and I can find the length of the hypotenuse, and that tells me the length of the between the 2 points. So that's how the distance formula was derived. Here is how it actually happened. So we have P and Q are random points out in space with a y1 and or x1, y1 and x2, y2. The length of A, this point right here is actually going to be x2, because it's x2 this way, but y1, because it's going up this way. Do you see that? Like if whatever these numbers were, so if this was like 5, no, that wouldn't be 5. This would be like 1, 3, and this would be 5, 6. Then this one would be 5. What's going on? 5, 3. It's going as far over as this x, but only as up as this y. Okay, so to find the length of A, what I would do is I would subtract x2 minus x1. That gives me the length of A. And to find the length of B is actually y2 minus y1. That is the length of B. So this is A and this is B, because we have c squared is equal to a squared plus b squared. So far okay? And then if you take the square root of this and the square root of this, you get c is equal to x2 minus x1, or x1 minus x2 squared plus y2 minus y1 minus y2 squared. And that is your distance formula. That tells you this distance right here. So far okay? Now, do you have to be able to create this on your own? Absolutely not, but you do need to know this formula. Just like you needed to know the midpoint formula, you do need to know the distance formula. It's between these two random points floating out in space. So this will be x1, y1, and this will be x2, y2, and I'm going to plug them in. Do not drop the square root off. So 6 minus 4 squared plus negative 3 minus 5 squared. The next thing I need to do is do the subtraction. So that's 2 squared plus negative 8 squared. At this point, everything you get after here should be positive. There should be no more negatives. So when you square the negative, you need to get a positive, because negative 8 times negative 8 is positive 64. And so my distance is equal to the square root of 68. And then I can check to see if it's simplifiable. And it is. I have a pair of 2's right here. And a lonely 17. So I pull the 2 out, and the 17 stays behind. Okay. X1, Y1, X2, Y2. Write this up here. Distance is equal to the square root of X1 minus X2 squared plus Y1 minus Y2 squared. No, I'll do the first 2, and then you guys can do the second 2. Okay, so distance is equal to 6 minus 3 plus negative 4 minus 0. I guess that should have been 3 minus 6. If I stay in order, it should have been 3 minus 6. So that gives me the square root of negative 3 squared plus negative 4 squared which gives me the square root of 9 plus 16, which gives me the square root of 25, which is 5. Questions on that? Then we'll do the next one. X1, Y1, X2, Y2. So the distance is 11 minus 13 squared plus negative 2 minus 4 squared. So that is negative 2 squared plus negative 6 squared, which is the square root of 4 plus 36, which is the square root of 40. And 40 is 4 times 10, and 4 is a perfect square. So 2 times the square root of 10. So why don't you guys try C and D and just make sure that, by definition, a circle is the set of all points in a plane at a fixed distance called the radius. Look, there's an I in there. From the center. So basically, this is just a series of dots, 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 all at the same distance away from a central point. Okay. The diameter is a straight line segment that passes through the center of the circle, and the end points are on that circle. And it's equal to 2 times the radius. We have a radius and a radius. The radius, which we just kind of went over already, but the radius is the distance from the center to any point on the circle, and this distance is the same all the way around because it's a circle. A chord is a segment with endpoints on the circle, but not the diameter. Actually, a diameter is a chord, but not every chord is a diameter. Okay, the diameter is a special chord that goes to the center, but a chord can go anywhere. It just has to be inside the circle. So here's a chord. This is a chord here. You can have the diameter to be a chord. It just has to, it stays inside the circle and touches in 2 places. A secant is a line that contains a chord. So if I come through like this line is the secant, and this part here is the chord. So a secant is basically a line that goes through a circle. And then a tangent is the line that touches the edge of the circle. It only touches in one point. It looks like it's touching all around here, but that's only because we can't actually draw a line as thin as a line technically is. It's really only touching in this one point. Okay, so I'll draw a picture here of everything. We have a radius. And then and different ways in the coordinate plane. All right, so if we take this and we want to use the distance formula, we know that 5 is the distance. That's the radius. So I have the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. That's our distance formula. This is distance. That's the length between here and here. So 5 is equal to, and then if I call this x1, or we'll just call this one x1, y1, and x2, y2, I have the square root of x minus 0 squared plus y minus 0 squared. So that gives me the square root of x squared plus y squared. And I don't want to keep the square root into my equation, so I'm going to square both sides. And I get 25 is equal to x squared plus y squared, and that is actually the equation of the circle with the center at the origin. So it's x squared plus y squared is equal to the radius squared. Okay, but the center has to be at 0, 0. That's the origin for this equation to work. So as you can imagine, this equation only works for a limit. I mean, it's an infinite number of circles, but it's not as many as if you include all the ones that aren't centered at the origin, right? Which brings us here. If I call this x1, y1, x2, y2, and this is still d, and I plug everything in the same way I did before, so I have 5 is equal to x minus 2 squared plus, it's x minus negative 2, so that's x plus 2. Y minus negative 3, so x plus 3 squared. And then I square both sides to get rid of the square root. I get 25 is equal to x plus 2 squared and plus y plus 3 squared. And this point right here is the center. Negative 2, negative 3. And so this gives us the actual equation of a circle with any center. And that is x minus h squared plus y minus k squared is equal to r squared, and hk is the center. So in this example up here, h is equal to negative 2 and k is equal to negative 3. So if you want to find the equation of any circle, if you know the center and you know the radius, you just plug them in. Like here. Here's the center, here's the radius. Center, radius. That's all we need, is the center and the radius. So x minus, so this is h, this is k, so x minus 1, y minus negative 3, and radius squared, x minus 1 squared, y plus 3 squared, 9. Done. That's the equation of that circle. Sometimes they'll just give us the 2 points. We have to find the radius first, because we have the center, but we don't know the radius. Okay, the radius is the distance between the point and the center. So I plug this into the distance formula. And it doesn't matter which one I call x1 and x2, so I'm just going to go in order. x1, x2, y1, y1, y2. So I have negative 8 squared plus 5 squared. So that's 64 plus 25. So that is 89, which won't simplify, but it doesn't matter. In this instance, don't simplify. Okay? When you're trying to find the equation of this circle, never simplify the distance, because you're just going to end up squaring it, right? Because it's the radius and then you square it. We have r squared. If r is equal to, let's say, the square root of 5, r squared is 5. The square and the square root cancel each other out. So we don't want to simplify it. It'll just be easier if we don't simplify it, because this is the number we'll need in that spot. Does that make sense? At all? Okay. The circle, again, is x minus h squared plus y minus k squared is equal to r squared. This is h, this is k. X minus negative 7, so that's x plus 7. Y minus 8. R squared, just take it out from under the square root. And that is the equation of that circle. See, it's a little bit more complicated. I'm given the endpoints of the diameter. So what I've got is I've got some circle with the endpoint here and here. Those are those points. I need to find the center. Well, the radius is half of the diameter, so the center is also the midpoint of that diameter. Okay, so first I'm going to need to find the midpoint. Then I need to find the distance, or the radius. Then I can do the equation. Okay. So I have to find that midpoint first, and we add 10 plus 2 divided by 2, and negative 1 plus 5 divided by 2. So that's 12 over 2 and 4 over 2. So my midpoint is 6, 2. This is also the center. Okay. Then I need to find the distance between this and either one of these points. I can use either point. Do you want 2, negative 1, or 10 and 5? 2 and negative 1, okay. So I'm going to find the distance between this point and the center. So I'll have 2 minus 6 and negative 1 minus 2. So that gives me negative 4 squared plus negative 3 squared, which gives me 16 plus 9, which is 25. Now I can do the equation. X minus 6, the center, plus y minus 2, center, is equal to the radius squared. So I'll do D here. If I'm talking about tangent to the x-axis, here's what this looks like. I've got, oops, that's the one I meant to. I've got my x and y axis, okay, and it's at negative 5, 3 is the center, so it's up here, right? And the circle is coming around and touching the x-axis in just one point. The place where it's going to touch the x-axis is going to line up. So it's touching the x-axis at negative 5. Okay. So this point, this other distance, or this other point right here is going to be negative 5, 0. And this point right here is negative 5, 3. And we can use that to find the radius. The length of the radius is between 0 and 3. So it's just 3. So far okay? So I know now that r is 3, and I know the center, so I can just plug those in. X minus negative 5, y minus 3, 3 squared is 9. So it sounds complicated because it's saying, oh, it's tangent to the, but it's actually easier than either of these two because it gives you this information. If it was tangent to the y-axis, it would be kind of the same idea. It would be touching the y-axis at one point, and whatever this point is here, that would tell you 0 to whatever that x value is the length of the radius.